I will be explaining you Cramer's rule in this video. So here it is theorem number 6.9.2. Okay, this is a very easiest theorem in this advanced algebra paper. Okay, so here you can see the statement. Let us follow my notes. That will help you to understand it. That will help you to make feel easy. Okay, so that is why my notes. So here you can see the statement of Cramer's rules. Can you see that? Let me read that. If the determinant, that is they are denoting determinant with this symbol. Determinant of the system of linear equations, also a system. Some of the linear equations also given. So you are calling it a system of linear equations. Okay, so is also given. They are saying the determinant of this system of linear equations is different from 0. It means determinant value you will write using this linear equations, and that value, the determinant value, is not equal to 0. That is what they are saying from this sentence. Then the solution of the system is given by this. The solution of this system is this. That is what we have to prove at the end. And they are saying where this delta I is the determinant. Delta I is also a determinant. Okay, that determinant, this determinant is obtained from where? This determinant delta. How it is, how you are getting from this determinant? By replacing the ith column in delta. In delta you will have the ith column. Okay, from the ith column you are replacing the ith column, and in that ith column you are going to put beta 1, beta 2, beta 3. Okay, so when you do this replacement in delta, then you will denote that it as delta 1, delta I. I'm so sorry, delta I. Okay, so that is how you are getting delta I. You will do all these things in the proof. Okay, so that is why in advance I told you everything. Okay, proof. Let us move on to the proof. So first you have to write given in the question. They are given you, right? Delta value is what? Different from 0. It means delta not equal to 0. Okay, so write that. Delta, you have to write the value of delta. You know that delta means determinant. The determinant you are going to write with the write from where? The system of linear equations. So this is how you have to write the determinant value from the system of linear equations, and put this not equal to and put this 0. Is that clear? And after that, what you are going to do is you are considering this. Okay, you are going to consider this, and by considering this you are going to do something. Okay, I will show you that. Multiplying, you are considered that, and what you are doing is multiplying the ith column. Oh my god, multiplying the scalar. You are having a scalar. Scalar means what? The element that you are taking from the field, that is called a scalar. So you are taking a scalar xi in the ith column, multiplying the scalar in the ith column of delta, so that you will get this. And this can be written like this, writing xi outside the determinant, and you can write like this. You can write this by using a lemma. There is a lemma. Okay, if there is a, in a column, if there is an scalar that got multiplied, then you can bring that scalar outside the determinant, and you can write the remaining like this. There is a lemma like that. Using that lemma you are writing like this, from this to this, and then this can be written like this. This is xi, and this value is delta value, so you are putting delta for each the value I equal to 1, 2, 3, etc. Okay, so keep that for some time without disturbing it, and then you are going to consider given. Okay, given delta I is equal to, in question, in our statement they are telling you how to write the value of delta I. That is what you are going to write now. Delta I is equal to, you are replacing the ith column with the beta 1, beta 2, etc. beta n. So you made it, and after that what you have to do is this step. In the place of beta 1, beta 2, beta etc. beta n, you have to substitute this value. Here you have beta 1, beta 2 values, right? Beta 1 equal to this, beta n equal to this, right? So you will substitute the value so that you will get this. Okay, in between don't put comma or something like that unnecessarily. Okay, observe it very clearly. After that you are splitting it. first this and then this in first determinant plus etc, and then you will write the ith. Okay, this and this in the here, and plus etc, and in this determinant you will write this. Is that clear? This and this. Okay, this is how you are splitting. Okay, can you understand that? This is very easy. If you observe it, you will easily understand. Okay, after that what you are doing is, here you are having here you see you are having x1 scalar, right? Here you are having x1 scalar in this row, so you are taking that outside. Okay, by that lemma, by using that lemma, you can take like that. So you are taking x1 of remaining plus etc plus here this is the value of delta xi. Okay, here you have, right? Oh my god, I'm trying to complete this video very faster, that is why. Okay, here you are having a value xi delta is equal to this, right? So that is why here in the place of this, wait a minute, yeah, the value of I'm so sorry, you are having this here, this and this are same determinants, so you've already found it, the value this is equal to xi delta. So here in the place of this you are substituting xi delta. Can you understand that? Yes, you will understand. Okay, so you are writing delta xi plus etc. Here is also you will have xn in the xn in this column, so taking this xn outside, so that you will get this. And now when you look at this, put this x1, and I will tell you how you are putting 0 here, because look at this row, this column and this column is same, equal columns. Okay, if there is an equal columns, okay, this column and this column are equal, therefore you will get 0. Similarly, look at this here, this column and this column is equal, two columns are equal means then the determinant will be 0, completely will be 0. That is what happening here. So after that this will become 0, this becomes 0, you will have only this. So delta I is equal to delta xi, you will get like this. Don't put delta in the suffix, okay, right? Somebody is thinking of me. Okay, so delta is equal to delta xi will get. From this you can find the value of xi. Xi is equal to delta I by delta. So this is what they asked us to prove, right? Finally you proved it. I varies from 1 to n. Thank you.